So the next talk was prepared by Nankao and Eurolin. Eurolin will present, and it's about Whisper, tracing the spatio-temporal process of information diffusion in real time. Long title. Thank you very much.
Okay. Thanks, Max. It's really my pleasure to presenting our little project here. I'm Eurolin and from Northeastern and Harvard Universities. My background is computer science, and I'm interested in study social network and political networks, as well as computational and visualization methods for network data mining. And here is our little project, Whisper, for tracing the spatial temporal process of information diffusion in real time. And I work with my colleague, Nan Chao. So the question we are asking here in this project is, how does an idea or a piece of information spread on social media? And social media like Twitter has been increasingly used for exchanging information, ideas, and opinions and emotions about events that are happening across the world. So for example, I log on Twitter and I search for earthquake. I see a bunch of tweets, and I can see a tweet that's information about 5.0 earthquake. And I also see a user retweet about an idea about earthquake. And in Twitter, retweet is that you tag some tweets that was posted by someone else, and then you rebroadcast the same message to your friends or followers. Okay, another idea is that I search for Mitt Romney, and I get a bunch of tweets about Mitt Romney. And okay, I see information about Mitt Romney. It says Jeb Bush endorsed Mitt Romney, and the user also gave her comments on what's happening. But what I cannot see here is whether this idea will be retweeted and where and how it will be retweeted. So the idea behind this project is to capture the key characteristic of information diffusion, when, where, and how the ideas are dispersed. And that would include the temporal trend, social spatial extent, and community response. And the main challenge of this would be how can we summarize the information diffusion process to facilitate pattern detection and comparison. And we can further break it down into several questions. How can we deal with huge amount of microblogging data in real time? How can we present the diffusion processes by considering temporal, spatial topic, and community information? And eventually, what can we discover? So we propose the Whisper system as a solution to the challenges. And the goal of Whisper is to visualize when, where, and how the ideas are dispersed. And here is the system overview of Whisper. Data gathering. So the system will collect the tweets in real time through Twitter API. And because there's only 10% of the tweets that have the geolocation information, so we recover the geolocation by utilizing the Google Geolocation API, and then store the tweets in a SQL-like database. And rendering, because the data can be enormous, so we need efficient online layout algorithms to visualize the data in real time. So I would talk about this later in more details. And interactions, the systems allows users to do online monitoring. And it has interface that allow users to do temporal exploration, spatial zoom, and user can specify query keywords and further refine the queries. So how can we represent the diffusion processes? So we need a language. So So our visual design is based on this sunflower visual metaphor. So let's decompose the sunflower. A sunflower is composed by thousands of disc florets in a circular head, surrounded by the ray florets. And the immature disc florets are on the center, surrounded by mature disc florets. And then the disc florets will become seeds that can be dispersed through wind, animals, or people. So to mimic the sunflower, we put a topic disc on the center that would look like disc florets in a circular head. And this disc are surrounded by the diffusion pathway, which will look like ray florets. And then the pathways are surrounded by the user groups. Users can be grouped by their geolocation, like countries, states, and cities. And the trees are emerged from the center in the topic disc. Like the immature and mature disc florets, we put inactive trees in the center, surrounded by the active trees. So trees become active when they are starting getting at least one retreat. And we put the retreats on top of the diffusion pathway. So the retreats will move from the topic disc to the user groups. And the ring of the topic disc represents the current time, and outside the ring will represent some time in the history. And the colors are including the tree colors and the user group colors represents the sentiment. Green for positive, red for negative, and yellow for neutral. And the size will represent the expected influence of the users. So that will include the tree size and the user group size. And the expected influence can be captured by the number of followers. And the shape of tweets represents the type of users. And a square for media outlets and circle for normal users. So then you know what tweets are important, because you can look at the media outlets or users with larger influence. Okay, so since an active tweet can generate a sequence of retweets, so when mouse over an active tweet, the diffusion series will be shown to illustrate who retweets whom and when. And here's the user interface of the entire Whisper system. You can highlight a tweet, and the content of the tweets will be shown, plus the diffusion series of the particular tweets will be shown in the button. And the tweet panels shows the incoming tweets in real time. And the timeline over here shows the volume of data coming over time and the average sentiments of each time window. And you can specify the user topic filter to determine the subset of data to be displayed. And you can click on the user group to zoom in into the detail about the user groups. Okay, you can pick a different layout and then specify different query keywords. Okay, so now I'm showing you a video to demonstrate the key functionality of Whisper. Real-time monitoring. So you can do real-time monitoring. For example, I can monitor on the keyword Obama, and then the tweets about Obama start coming in, and you can do an interaction on your data. The tweets are gathered and visualized in real time, and you can change the layout into longitude layout, so the users are layout based on their longitude information. And you can click, you can mouse over the tweet to see the content of a particular tweet, and then wait for the data coming in. because it's real-time monitoring. And then you start seeing there are different kinds of sentiments about Obama when we were recording this video. And you can click a particular tweet to see how the spatial, what's the spatial diffusion pattern of a particular tweet. And since the tweets were retweeted by different countries, including USA, Japan, and different countries, so you can zoom in, click the particular country, and then the user group will change to a state, and you can either zoom into a particular city, and then zoom out to see the global view of the spatial pattern. And you see on the bottom is a volume of the data. Also, you can load the data that you recorded earlier and do re-exploration of the data. So here is earthquake data. It's about a Japan earthquake. And we will talk about this example later. Okay, so I'm going to give you a brief overview about the layouts. And since the data is coming in real time and can be enormous, so we need efficient layout, and we need to reduce as much as possible the visual clutter in order to display the data. So for layout, we first lay out the topic disk and then the user group. And then we draw the diffusion pathway to connect topic disk and user group. And then in the final step, we reduce the visual clutters. So for topic disk, we lay out this topic disk based on this sunflower packing algorithm. And for user group, we lay out the user groups. We can lay out the user group in the outer ring of the circle in equidistance. And when the user were grouped by their geolocation, we can lay out the user group based on longitude information. And within each user groups, the tweets can be laid out using Voronoi or sunflower packing algorithms. What? Okay, and the diffusion path line diffusion path line are drawn on the diffusion field, and this is based on the idea or the concept of electric fields. So we consider a bipartite graph. The two modes were topic disk nodes and the user groups. And we put positive charges on the topic disk and put negative charges on the user groups. And then we draw the diffusion path line as flux lines. And the flux line has two key properties. One is that the lines are repelling from each other, and the other is the lines have tension to make themselves shorter. So you can then reduce much edge crossing of the flux lines. I'm sorry, it's okay. And in the final step, we further reduce the visual clutter, so we can. So to reduce the edge crossing, we can reorder the position of the active tweets. And then we put a force model here and then rotate the topic disk in order to shorten the flux line. So finally, what can we discover with Whisper? So here is the example about the 6.8 magnitude earthquake in Japan in March 2012. So we can use Twitter to trace, Whisper, to trace this diffusion about this earthquake. So this is a screenshot about the tweets that are coming in. And you can see there are a lot of retweets about this earthquake going to different countries. And Japan, most of the information were related to Japan. And there are different kinds of sentiments going to different places. Specifically, we can see negative tweets like users from Australia. They were worried about the tsunami caused by the earthquake. And positive sentiment, like users from Philippines, they were celebrating the safety of a celebrity here. And we can see trends and bursts. So, for example, you can see a sequence of continuous earthquake report were announced and retweeted from Japan. And you can also see multiple tweets were retweeted at the same time from friends. And we also monitor the new iPad release in March. And you can see there were a lot of tweets, pretty dense, because Apple's friends are coming over the world. And you can zoom in into a particular country and then zoom in into to see the interest from different communities. And we can also trace the media and the opinion leaders. So we monitor the 2012 Republican primary on Super Tuesday. So if you were remember that the Ohio State election is pretty intense. So until midnight, people don't know who win the election. So AP is the first media outlets that report the Romney's victory. And you can see it got a lot of retweet from many states. And you can see the spatial patterns about this diffusion. And here's another media outlet, WSJ, that retweet the same message after AP, and it got a very different spatial diffusion pattern. And also opinion leaders were also commenting these events, like Congresswoman Scouts. She made negative comments on this Romney victory. And you can also compare the diffusion series about different media and compare the visualize the temporal patterns about media opinion leaders. So in summary, the thing I'm going to highlight here is Whisper is a real-time interactive visualization for monitoring and exploring the information diffusion from microblogging data. And the visual design is use the Sunflower metaphor, and we conduct an evaluation for this and then get pretty nice results. And here are a bunch of next steps we are working on. And special thanks to Lazar Lab and Professor Isabel Mezzarello and my InfoVis co-author. And this paper has been recently accepted in the InfoVis this year. And okay, thanks.
Much. We're a little bit tight in time, so while Aliyah attaches the computer, I would say one question. So, anyone? So, okay. So I have one question actually. At the New York Times Research Lab, Charles Thorpe did something very similar, and it's used at New York Times by journalists to actually investigate the popularity and basically the effect of their own articles. Could you imagine, or are you already collaborating with people where people use something like that? So are you in contact with people who would actually use that? So, or is this just an experiment, or are you what is the key audience? Is it journalists? Is it regular people? Is it?
Yeah, we think the key audience. Oh, we think the key audience would be the journalist and political analyst, and. But I think people have been trained have more and more visual literacy to do data analytical work, and then I think there are a lot of like geeky users that would like to use this. Yeah.
Okay, let's thank Guru again.